to the right or to the left?
Right.
To the right, to be aligned with its velocity vector, okay? So I need n to be positive to the right, because n to the right is positive, l to the right is positive, and vice versa. So when the airplane is slipping to the right, I need two things to happen naturally without the interference of the pilot. I need the airplane to roll to the left and yaw to the right. I never want roll and yaw in the same direction because the airplane will depart. Okay? I need roll to the left and yaw to the right. So this is L beta due to the dihedral and whatever, and this is N beta due to vertical tip. Okay? Let's see what happens. So this inequality tells you that if this guy is much larger than this guy, things will become unstable. And we need to know why, physically, from flight. If this guy is much larger, and this guy is small, okay. Because this is large, I will get large yawing moment positive to the right. Yawing moment will cause what? If the airplane is experiencing a yawing moment, what will happen? Will yaw in the same direction. So I will have velocity r in the same direction. And we just said that there is something annoying called CLR. If I have an r, if I have a yawing angular velocity, there will be a rolling moment in the same direction, right? And if this guy is large, this guy is large, this guy will be large, and this guy will be large as well. Okay, the story ends here. Over there, so because of this L beta negative, I will have a negative rolling moment to the left. This is what we discussed, dihedral. But because this is small, this is also small. Now I have two competing actions. If this guy, because N beta is much larger and L beta is smaller, the rolling here will be larger than the rolling here. So let's recap. At the beginning, I have side slip. Okay? I have side slip. The immediate action is, well, roll to the left if the airplane is stable, and yaw to the right. That's fine. But eventually, because of this story, what will happen? This yaw to the right will cause roll to the right as well. And this roll to the right is larger than the roll to the left that generated at the beginning. So what's the end result? Is that the airplane is yawing to the right and also rolling to the right. It will depart. It will cause spiral. Keep rolling. And of course, if you keep rolling, you will lose altitude. So this is your spiral. This is what we call the spiral mode. And you can see now the approximation is very essential to tell us this story. So what is the solution? Just 1 minute. What's the solution? I have here CLR and CN beta. This should be less than CNR. What's the solution? I need the left-hand side to be larger than the right-hand side. How can I do it? This is inevitable. This is dictated upon me. I have no control over. It's the lift coefficient of the airplane. I cannot change it. It's an operating condition. This is, how can I decrease it? By decreasing the vertical tail size. But now you're messing with what? With the Dutch roll mode. This is the speed of the Dutch roll mode. You don't want to decrease it. Okay, let's increase the other side. Well, if you increase the CL beta, what will happen? Again, the Dutch roll mode will become unstable. This was just discussed, right? The CL beta. And what about the CNR? That's great. This is yaw damping. So how can I increase the CNR? Increase the vertical tail. But increasing the vertical tail will increase this guy by the same amount. You didn't do anything. So the only solution to this problem is to increase the CNR artificially. This is called yaw damper, and every modern airplane is equipped with a yaw damper. Simply, this is your airplane. We put a gyro here to get the R angular velocity, measure it, and go and multiply your R by some gain to be designed. And then this is the pilot command. Take this to the elevator, to the rudder, servo, this is delta rudder. So it's as if your delta rudder, the change in the rudder from the pilot, is something that is proportional to R. Simply measure your R and multiply it by a gain. Then the change in your Cn is simply Cn delta rudder times this delta rudder. So Cn delta rudder times delta rudder is K times R. Now look at this. Change in Cn equals something times R, so this must be CnR, right? So it's as if you're artificially creating NR, yaw damping. So your total CnR will be simply whatever you have from before. This is the physics of the airplane, the vertical tail, CnR here, okay? The vertical tail action. Plus this delta CnR artificially, okay? We're done. See you in a week, okay? There's no Monday or Friday.